Hey everyone, I'm Zack DeRose, and I love building awesome things. That's why I'm in software engineering. I'm a GDE in Angular, as well as a senior engineer and engineering manager at Nrwl. I'd love to talk with you today about how to get the most out of using NX. And I'd like to start that discussion by talking about understanding tools. Several years ago, Victor wrote a great article on skills that helped him become a better software engineer. My future self should be sending a link to this article in the chat now. In this article, Victor lays out the importance that tools play in our efforts as software engineers, and I think also as humans, but that's a story for another time. Per Victor, a tool can be something very specific, like Jest or Cypress or TypeScript, for example, but a tool can also be very high level as well, such as a keyboard or even pen and paper. We employ our tools because it makes us better at optimizing our resources to produce our output. Sometimes we may make a choice to invest in our ability to learn a new tool, like a new framework, or maybe a new keyboard setup or a journaling technique. If our motives are pure, at least from the point of view of engineering, we make this investment based on the promise that learning this tool will accelerate our ability to produce output. I think we should try to understand NX as a tool set in this way. Our motivations for using NX should not be because of some dogmatic obedience to some school of thought, but rather its ability to optimize our resources to produce better results. Which leads me to my second introductory point, dollars and cents. To add some further context to this talk, I wanted to highlight what I think is one of the cardinal sins of engineering, and in particular software engineering in our era, being penny wise but dollar foolish. As we previously mentioned, engineering is the process of optimizing resources coming in to products going out. In our line of work, developer time and developer ability appears to be the input of most importance and is proving to be a still appreciating asset. In other words, developer time is the dollars of my metaphor. Software engineering salaries continue to climb higher and higher, while costs of computation power, memory, equipment, infrastructure, and etc. continue to be driven down. Neither of these trends appears to be letting up anytime soon. This is why I'm particularly long on NX, because in my opinion, NX is the premier toolset for both, number one, reducing developer time via tools like generators, affected commands, computation caching, NX Cloud, and etc., and also number two, accelerating output for the time that is spent by encouraging good architecture and modular design. The second point is what my talk will primarily focus on, starting with Nrwl's baseline recommendations. Nrwl has published a book entitled Enterprise Monorepo Patterns, written by Victor Sadkin and my former colleague and mentor Nitin Verachurla, with contribution from Thomas Burleson. Again, my future self should be sending the link to this resource now in chat. It's free. The book provides the foundation for how we tend to build NX workspaces, and any advice or considerations I'll give in this talk are built on top of this foundation. To paint with a very broad brush, the recommendations given amount to: number one, apps should amount to shells that are constructed almost entirely by libs. Number two, libs should be categorized by scope. Scope can refer to front-end, back-end, or shared. Scopes could also refer to other levels of domain in your workspace, such as an application's name, for example. Number three, further categorize libs by type. The prescribed types of the book being feature libs, data access libs, presentational or UI libs, and util libs. And finally, use tags to enforce the rules so that a given lib can only depend on libs of appropriate categorizations. My future self should be sending a link now to our official documentation site where you can see how to set up a tagging structure for your own workspaces. In addition to recapping the canonical NX recommendations, this presentation will be supplementing these with additional resources I've personally come across through my experience working as a consultant for Nrwl on teams that use NX. The first of these recommendations is being proactive with the depth graph. This is perhaps the most impactful piece of advice I can give in this talk. In my opinion, the depth graph is a criminally underrated tool for analyzing your workspace, I'm very much looking forward to my colleague Philip Fulcher's presentation on some of the newer depth graph features coming up after the break. I've been very impressed with the work he's done there lately. Without going too deep, though, on the depth graph's newest features, the core of the value that NX Depth Graph tool provides is giving your team an accurate, on-demand visualization of the state of your workspace and how your libraries and applications interconnect. As a piece of advice for you and your team, I highly advise opening up your depth graph on a periodic basis to check in on the state of your workspace and ask yourself the following as a team. What would your ideal graph look like? How is your graph not currently ideal? What would it cost us to get to the ideal state, and how much would that benefit us? I'd also advocate, when planning out future work, pulling up the depth graph together and discussing if the depth graph should change, if the work should be encapsulated with a given lib, if a new lib is required, or if it requires a larger shift in the workspace as a whole. These types of discussions can help provide clarity to a problem. They can also help the team get a better feel for your workspace, how it is evolving, and how it should evolve in the future. Keeping in mind our dollars and cents principle, the case of being proactive and pruning or making changes to optimize your depth graph, I'd argue that the cents value is the build time optimization gained by running affected commands with NX, while the dollars value actually lies in the development acceleration gained by your team by having solid architecture to your workspace in place early, while continuing to be mindful of the architecture of your code base as time goes on. Good architecture can work as an anti-tax received daily by all members on your team, and it can work wonders in terms of increasing output. Part of what makes being proactive with your depth graph uniquely beneficial, though, is in this case, the interests in optimizing for your dollars and for your cents are not competing, and are actually, for the most part, fairly closely aligned. Better architecture leads to better optimization of your build times, and getting better optimization for your build times of the affected command generally leads into better architecture. The result is that making the smaller investment of being aware and proactive of your depth graph can pay significant dividends in terms of your team's developer velocity over time. The next piece of advice in my talk I'll be giving is called the Goldilocks Principle of library sizing. One question that we at Nrwl often receive is, how large should our libraries be? The answer I often give is, it depends. So I'd like to take the opportunity to dive a bit deeper into that question next. Let's consider the reductio ad absurdum, or reduction to absurdity, to the argument for both large and small libs, and work from there. The argument for large libs looks something like this. And that is a perfectly possible NX workspace. But at this point, there's not much point to using NX, as we're not breaking into modules. There's essentially no graph to optimize, etc. So clearly this is not the desired outcome. Let's swing around the other way and do the same for small libs. To do that, I'll introduce a new acronym, SFNL, or Sniffle, or Single Function NX Library. In this scenario, the amount of generated config files and structure far outweighs the actual code we're writing. NX can come in and be very highly optimize our graph, so that's actually a big positive. But we fall into the trap of optimizing for cents here instead of dollars. As a graph this intensive starts going beyond the bounds of a human mind to fully understand, even when evenly divided amongst your team. So obviously the two absurd workspaces we mentioned are wrong. So the answer logically lies somewhere in the middle, hence a Goldilocks approach to size. Not too large, not too small. In other words, it depends. Before leaving you with an entirely unsatisfying answer, though, I would like to offer a couple of pieces of actually helpful advice regarding library size. First off, a very helpful mental model when you're working with NX is to imagine each lib as an NPM module that just happens to live within your workspace. Basing your lib size on that mental model may prove helpful in deciding whether a library has gotten large enough that it ought to be broken up in two or not. The second piece of advice is this. If you're new to NX, it's very likely that your tolerance for how small a lib can be may be worth coming at with a fresh mind. As we saw, the negatives of small libraries are more config to maintain in your codebase. These negatives are actually dampened by NX's ability to generate that config via generators and to maintain that config going forward via migration scripts. On the other side, the benefits of more granular separations in a non-NX environment are also amplified in an NX workspace by the NX tooling available. Better affected command optimization leads to better build times. All this to say, it seems to stand to reason that coming into NX as engineers that are always optimizing, we should expect to see a natural shift in our preference towards smaller libraries than we would otherwise have been comfortable with without NX. Next up, avoiding bucket libs. This piece of advice comes from seeing this happening in the wild quite a bit, and I'm guilty of this myself. A lib operating as a bucket for random stuff you can't find a better place for. This lib may be labeled hooks if you're working in React, or may be labeled middleware if you're working in Node Express, or it might be labeled pipes or services if you're working in Angular. In many ways, these kinds of libs are very tempting to set up, and even more tempting to drop code into once they've been set up. The problem is that they tend to create bottlenecks in your workspace, where most or potentially even all of your workspace above that lib is affected by a change to the lib. The way this tends to show up is if you update some code to fix a bug, for example, on how your workspace formats dates. Since the code is bucketed, since your date formatting code is bucketed with all kinds of other random hooks or pipes or services or middleware, you end up making your entire workspace appear affected, even the parts that don't actually use your new date formatting code. This leads to longer CI and build times, but perhaps more importantly, it gives you an incorrect view of how your workspace is actually architectured and maybe how it ought to be architectured. While I brought up the idea of an entire workspace built entirely of sniffles in the previous section as an absurd thing not to do, I'm not necessarily opposed to a S*Nrwl library, provided that the existence of the libs provides some meaningful value and your code base or mental model thereof is not rendered unusable by the excessive use of sniffle libraries. In other words, sniffle away, but as with all things, a healthy amount of moderation goes a long way. Isolating nodes in our depth graph. This is more of a novel idea, but I've had some success with this in the past and on some personal projects. But I want to make sure I preface this as an idea to explore. The idea amounts to the following. Each one of our libraries amounts to a somewhat sufficient module. Theoretically then, for any node in our depth graph, we could create an application project specifically for that library. For presentational or UI libraries, for example, you could stage your components in isolation in an actual application, using it as you would in a real-world scenario. I'm of the opinion that apps for presentational or UI libraries can also serve as a great living documentation example for how components ought to be used. I want to be sure to mention Nrwl's NX Storybook plugin, which can do essentially exactly what I just described in a streamlined fashion thanks to the generators and executors available there out of the box. Adding an application for a specific feature library can also have a series of unique benefits. For example, serving up an app with a specific feature in isolation can be great for capturing a bug and figuring out how it needs to be fixed. This is further enhanced by NX's ability to generate a working Cypress application for your application and automate your recreation of the bug in this way. It's also very possible, given your workspace or application size, that serving a much smaller, more focused application can help decrease your cycle times. So in summary, if this idea catches your imagination, please go try it out. And please let us know if the value you get out of it is worth the investment. Even if you don't actually try it out, I think understanding how it could work can be helpful context to your mental model for NX workspaces, and therefore hopefully worthy of your consideration today. My final piece of advice: the problem with hierarchies and how to bust them. I've saved the best for last. My original pitch for this talk was focused solely on this one principle, and I'm super excited to share this principle with you today. So to introduce this topic, let's take a real-world example. Suppose we're adding a messaging feature to an existing web app in our NX workspace. This feature will periodically send the state of our current user's client state via network request to an API, which will return any messages that the user should see on their current page they're looking at. For the sake of this example, let's focus in on how this would work with the dashboard feature lib and its corresponding data access lib. The question I want to zero in on is what should depend on what when it comes to your NX libs and your def graph. Should your messages data access lib depend on the dashboard data access lib? After all, we'll need to pass our dashboard state to our messages request. Or should the data access lib depend on the messages data access lib, as the messages response will affect the dashboard state? What I tend to see in these situations is a decision to go one way or the other here. And whichever way you decide, you end up creating a hierarchy where A must depend on B, and B can never depend on A, or else you create a circular dependency. The problem is, sometimes B really seems like it should depend on A. And as you keep working, you must always be mindful that it can't. This is the problem with hierarchies. They tend to create these wrinkles in your graph that start charging taxes on your resources, your developer's time. So what if I told you there may be another way? By splitting up the data access libs into a lib for their external interfaces versus their internal implementations, we can effectively fix the hierarchy problem. The wrinkle in our depth graph can no longer exist. To make this example more concrete, let's make each data access lib specifically use the NGRX state management library. When we split up each lib into an interface versus an implementation library, the way NGRX works, we can put the following into our interface lib: the TypeScript interface that specifies the shape of our state object, the action creator functions, which are functions that create objects to describe events as they happen in our app, the selector functions, which are functions that allow us to retrieve situational data from our state object. The reason these are split out is because they serve as the external interface to our state management, meaning these are the pieces that other features or implementations need to know about in order to operate. Meanwhile, the implementation lib contains the reducer function, which is a function that creates a new state object from a current state object and an action object, any effects classes that are used for triggering side effects to certain events being observed, and the Angular module, which is used to package up the reducer and effects into a pluggable module for the Angular framework. While these pieces serve as the actual engine for how your state management code works, to all other modules of your workspace, this is really merely an implementation detail, or the black box of your code. I'm hoping even if you're not familiar with how NGRX works, this concrete example will help you translate the difference between an interface and an implementation, and how you can use this principle to iron out hierarchy wrinkles in your workspace's depth graph, as the principles behind this pattern extend beyond NGRX and beyond data access or state management libraries as well. At the heart of this principle is simply the OG gang of four principle of coding to interfaces. Long before NX entered the scene, the benefit of separating out an implementation from its interface was well understood. And the motivation for doing so is partially based on this hierarchy/circular dependency problem, which, believe it or not, also existed long before NX. And before wrapping up, I do want to make clear that I don't believe you should immediately go out and split all of your libs in two. This appeared to be the takeaway of some of the heavier object-oriented programming languages that will always define an interface before creating a class. And I believe that pattern often leads to unnecessary bloat. This is merely a tool that you can now have in your tool belt for dealing with this issue as it arises. And it is my experience that it tends to arrive very often. But at the same time, not every lib is a nail for your new hammer. That's about it for my time. I want to make sure to thank everyone here for spending your valuable resource of your time on me. I hope it will prove a worthy investment, and some of my advice can pay dividends in your efforts. If you've come across any other great principles for architecting NX workspaces that you'd like to discuss, please reach out to me on Twitter. I'll be looking forward to the Q&A session here as well. I also have a link here to my website where you can find links to other talks I've given, blog posts I've written, and podcasts and videos I've made. Here's to moving forward and building awesome things together.